My name's Tim Petterson. I'm a team lead at Atlassian, and over the last few years I've developed plugins for Jira, Fisheye, Crucible, and most recently I've been working on a big cross-product plugin project called the Unified Application Links plugin, which I'll be presenting in a lightning talk this afternoon. But this morning I'm going to be talking to you about understanding the Atlassian platform. So I might just do a quick survey actually. How many people in the room consider themselves to be Jira plugin developers? Okay, cool. That's maybe about 20%. And how many people would consider themselves to be Confluence plugin developers? Right, cool. And how many people have successfully developed plugins for both products? Okay, yeah, so still a fair few people. Well, for those of you in the room who haven't ever developed a plugin for an Atlassian product, there's traditionally a few problems you can run into along the way. One of those problems is upgrades. When you first develop a plugin, you can run into issues when you upgrade the version of Jira it's deployed to. Or if you manage to get it compiling against the new APIs, you can have issues with the Jira team or the Confluence team switching out the new UI from underneath you and your plugin just looks horrible. Another issue that you can run into is actually building the plugin in the first place, as the internal Jira APIs and Confluence APIs that you're used to depending on are pretty hard to follow because they're not really designed with external consumption first and foremost in mind. But I'm here to tell you this morning that there's a solution to these problems, and it's just around the corner. Presenting the Atlassian Plugin Development Platform. Now, as Don mentioned in his State of the Union plugins address yesterday, Atlassian have started rolling out a consistent set of libraries and modules to all of the Atlassian products. This effectively means that you can code against one API. Why is this a good thing? Well, for one, it's the first Atlassian project that's targeted directly at you, the external plugin development community. It's jam-packed full of features. Some of those I'll be going through in this presentation this morning. And we've got a dedicated team at Atlassian who are solely responsible for responding to your feedback and making sure that we continue to push out new versions of the platform. It's also far better in documentation standards than the internal APIs in Confluence and Jira that you're used to coding against. Plus, and possibly most importantly, there's a strong focus on backwards compatibility. So you won't have, well, we'll be trying our hardest to make sure that your plugins don't break with subsequent plugin releases and product upgrades. So today, I'd like to take you through a few of the different components that make up the Atlassian platform. I'll show you how to import them and include them in your plugin, and I'll give you some practical examples of how you can use them and use their APIs. But first, I'd like to give you a little bit of a demo. I'm going to show you the Atlassian Hovers plugin. This is a cross-product plugin, and it's a little bit special because it's been developed almost exclusively using the platform APIs. If you want to check out the source and follow along, just follow that bit.ly URL because we're looking at some practical usages of, well, some practical implementations from this plugin later in the demonstration. But first, let's take a look at this demo. So here we have a typical Jira issue view. It's referencing a bunch of basically a bunch of entities that exist in other Atlassian applications, and these applications have been linked to this particular Jira instance. Now, the problem with linking other things, the problem with referencing entities that exist in remote applications is usually that you have to click through to that remote application to see what's going on. But the Atlassian Hovers plugin solves this by providing a little inline tooltip with information about that remote entity. So here we've got to change that with some information from Fisheye, or a Confluence page with a little bit of data, a Bamboo build, and another Bamboo build, this one's green, and a Crucible review. So the idea is that a user can see a whole bunch of information inline without having to leave their Jira context. Let's just switch back to the presentation. So yeah, pretty cool, hey? Now let's go on and have a look at some of the components that comprise the Atlassian platform. Have you ever needed to communicate with a remote application from inside your plugin? Or have you ever wanted an easy way to provide JSON data for an Ajax UI? Or have you ever wanted to expose your plugin's data via web services so external consumers can consume them? If so, the Atlassian REST plugin could be what you're looking for. Now, the REST plugin does exactly what it sounds. It allows your plugin to define new REST resources and return REST data via endpoints, and also provide some handy client utilities for doing client-side REST. Before we look at how we actually use the REST plugin, let's step back and take a look at how you would need to include it in your POM. There's a variety of different modules you can include. I'll just step through them quickly, and it can be a little bit confusing, so I'll just tell you exactly what's included in each of those. There's the Atlassian REST Common module. It contains all of the Atlassian annotations and utilities you'll need to use client-side REST and mark up your REST resources. There's the Atlassian REST module, which contains all the JAX-RS annotations you'll need for building your resources and Jersey itself. And then there's the JAX-B annotations, which are part of the JAX-B API. These will be used to create the entities being returned by your REST resources, which we'll see in a moment. Just a quick departure, actually. If you have a look here, we've got a whole bunch of version elements specified as children of those dependencies. Now, traditionally, when you include an Atlassian component, you needed to specify which version you wanted to depend on. However, since we're now pushing out consistent versions of these different modules as part of the platform, instead, you can depend on our dependency management POM. What that involves is just adding this little dependency management element to your POM, and then you can omit that version element that you see as a child of those dependencies. If you want a little bit more information about migrating to this, just check out that link at bit.ly, platform versions. Of course, you can still continue to specify versions per module if you like, or if you want to override it for testing purposes, but there's really no need to anymore. Anyway, back to REST. Now that we've got the dependencies on the REST plugin in our POM, you'll need to add a REST descriptor to your Atlassian plugin XML file. Now, the REST module is quite easy to use and quite easy to configure. You just need to give it a key and potentially a description. But the most important attributes to look at here are the path and version attributes. What these are used for is defining the path which the REST resources in your plugins will be accessible from. So if this particular plugin was installed on our public Jira instance, all resources defined in this plugin would be accessible under this path, REST SumPath 1.0. That version attribute is a handy way of maintaining a consistent version with your plugin's REST resources. So when you release a new version of the plugin, if you've changed the REST API, you should increment that so consumers know exactly which API they're talking to. The other element in this Atlassian plugin XML file is just that component import. It's basically a... hold on one sec. Am I running in full screen? There we go. That's a bit better. All right. Is that component import module. That's basically importing another client-side REST component called REST URL Builder, which we'll be looking at a little bit later on. But first, now that we've defined our REST module, let's look at creating a resource. So it's pretty neat. The REST plugin initializes Jersey, and Jersey doesn't. And you don't need to. When you create your resource, you don't actually need to register it anywhere else. All you need to do is add this little annotation to your resource class, the path annotation. That path specifies the subpath of your plugin's REST path, which methods on this REST resource will be invocable under. So because we've specified hello there as the path, that just gets appended to our plugin's REST path. The next couple of JAX-RS annotations, consumes and produces, basically just set up the media types which are supported by this particular REST endpoint. If you look down at the method annotations, that next path is used to define the actual path that this particular method will be invocable from. So you'll notice in that particular path annotation, we've specified a little name in curly braces. That's a really neat little JAX-RS way of getting a variable part of the URI injected into your method signature. So if you look down at the signature of hello, there's a path param annotation with a string name. Basically, whatever the client specifies as the last part of their REST resource will be injected straight as a string into that method, making it really easy to use. That next JAX-RS annotation, a get, is just specifying which HTTP method we want this particular resource to respond to. You can use delete or custom method types if you like. And that last annotation, anonymous allowed, is a homegrown Atlassian annotation for interacting with your host application's authentication stack. By default, REST resources deployed using the REST plugin will return just a 401 for any request that isn't previously authenticated. However, you can override this behavior by specifying this little anonymous allowed annotation. All right, so before we move on, just the last thing to look at on this slide is the message entity that's being returned as a response to that hello invocation. That's a JAX-B entity, which we'll be looking on the next slide, and that's the last thing you'll need to do before you can test this REST endpoint. So creating an entity is very much like creating a resource. It's all annotation driven. You don't have to register this guy in any of your Atlassian XML files. All you need, it just needs to be accessible to that resource so it can construct it. First of all, you need to add an XML accessor type annotation. That defines how this particular entity will be marshaled when it's converted into XML or JSON or what have you by Jersey. Since we've specified the field value, it'll just iterate through all the fields on this particular class and write them out to XML or JSON for you. The XML root annotation just marks that this entity is actually able to be returned by Jersey as the root element of a particular response. The name equals message is just overriding how that'll look when it's displayed in XML or JSON again. So then we've just got a really simple message entity class. And once you've deployed this, you can start testing. So you can test with a command line utility like curl, or you can just use a simple web browser to see what your REST endpoints are returning, or you can use the poster plugin that Andreas mentioned on Monday. I highly recommend this because it's got a nice little graphical user interface for Firefox for submitting requests to any sort of endpoint. And you can modify which HTTP method you want to use, modify the request headers, inject entities into the body, all that kind of stuff. Really handy. Just the last thing on this slide before we move on. Down the bottom, I've got a couple of example responses from what this particular REST resource would look like. So we've specified the full path, and at the end, in the first one in the blue square, we've appended a little .xml suffix. Now, what that does is it forces Jersey to marshal the response as XML. And the second one, we've appended .json, and it marshals the response as JSON instead. So this can be just a handy little trick for opening up your particular REST resource to a whole range of clients. And that's basically it for resource creation. It's pretty simple. Moving on, let's take a look at some of the client-side REST, which we've recently introduced into the REST plugin. Here's an example. So this is the REST URL builder, which we imported earlier in the Atlassian plugin XML file. Don mentioned this in his plugin State of the Union address yesterday, so I won't go into too much detail. But basically, it's just another type-safe way of generating a safe URI. So this assumes that you have the host REST resources accessible on the client side, maybe through some sort of shared library. Or if you're writing a cross-product plugin, they'll probably exist within the same jar anyway. Basically, all you do is you call getURL4, pass in a base URL, and the resource and the class of the resource that you want to target, and then you get returned back a typed stubbed out version of that class, which when you invoke a method on it will return a response, and you can call toString, and it'll just return that REST URI. Again, just a really nice, simple, clean way of getting a REST URI. With the REST plugin, we've really tried to make REST as easy as possible for you guys to use. We also have a couple of ways of doing nice transporting entities in Java. Here we have a simple request factory. This is actually provided by another plugin, by another platform component, the SAL API. It's just basically a simple little HTTP client library for creating simple HTTP requests. But most recently, we've provided an additional method called getEntity. So what we're doing here is creating a request. It's just a GET request targeting our resource, which we've just created, executing that request, and if it's successful, we want to unmarshal that entity into Java. So rather than having to do any of that XML handling or JSON handling ourselves, we can just call this simple getEntity method on the response, pass in the class we're expecting, and it'll do all that unmarshalling magically behind the scenes for us. So again, just really nice and easy to use. Here we have an example of the reciprocal of that. This is marshalling an entity. So if you look down in that little server box, we've defined a REST resource that actually accepts a message entity as one of its method arguments. So that indicates to Jersey that there's going to be an entity in the body of the request. Now, rather than trying to assemble that by hand, we can, again, just use Sal's setEntity method to set the entity on the request itself. And we don't have to worry about any of that marshalling or unmarshalling. So if you've got control over the client and server side of a particular application, this is a really nice way to pass data between to local and remote servers. Before we move on, I'll just show you a practical example, a bit of code where we've actually used these technologies together. This is a part of the hovers plugin we just looked at, where the local application is querying out to remote applications looking for content to render in those little hovers. So you'll see we're using a request factory to create a request, just invoking the URL builder. hitting a content resource class. That content resource returns the HTML for the particular issue or Crucible review or Bamboo build or whatever that you're looking at in the remote Atlassian application. And then when we execute the request, if it's successful, we unmarshal that straight into a content entity object, ready to be used. So I think that's about enough on REST for the moment. So let's move on to the next component. Have you ever wanted to launch a modal dialog from your plugin to really grab the user's attention? Or have you ever wanted to add rich tooltips to your content to hide away bits of the UI that you might not need to see until the user actually requests it? Or have you ever wanted your plugin to look and behave a little bit more like the host application, have a bit more of that Atlassian style? Or have you ever wished that someone else would write all of your CSS and JavaScript for you because you're a backend developer and you don't like it? Well, the Atlassian User Interface plugin, or AUI, may help you out. AUI is basically a suite of rich UI components that you can add to your plugin and a set of Atlassian styles that you can apply to your own components if you like. Depending on AUI is a little bit different. Because it's a user interface plugin, it doesn't actually contain any Java code or components that you can import. Rather, it's got a set of web resources, which you can depend on using the Web Resource Manager. Now, the Web Resource Manager is a core plugins framework component that you can use to include resources from your own plugin or other plugins in your plugin's views. So the first method you'll need to invoke, here we've just got a simple servlet, so it's running inside the context of a request. And you can invoke this require resource method and pass it in a context key. What this does, pass it in a web resource key. So what this does behind the scenes is it goes off, scans all the plugin.xml files looking for this web resource, and grabs all of the resources that live under it, whether it's JavaScript or CSS files, and binds them to the current request. Then, if you inject that Web Resource Manager into your Velocity template that's rendering the view, you can call the getRequiredResources method, and the Web Resource Manager will spit out all of the link and script tags that you need to get those resources included in your page. This is a much nicer, more reusable way, more maintainable way of including resources in your plugin files rather than trying to write them out by hand. This is a bit of a contrived example because you probably won't want to depend on AUI or import AUI directly into views like this. More likely, you'll probably have your own web resource with your own script and CSS files, and you'll declare a dependency on AUI in your web resource. So in this Atlassian plugin XML file at the top, we've got a couple of resources. Possibly they interact with AUI. And we've got a dependency declared on that AUI module key that we saw before. Once you've declared that dependency, when you call the require resources method within the scope of a request, it'll go off and look up all of your web resources and then follow that dependency over into the AUI plugin and get all of those and aggregate those and attach them to your request as well. So when you write those resources out to your plugin view, they'll all be rendered as nice sort of script and link tags, and you'll have it all of your scripts and styles included in your plugin view. So now let's take a look at some of the things you can do with AUI. So here's a quick example. Zach's going to give a more in-depth talk about this afternoon, so I'm just going to show you a couple of really simple APIs just to get you started and get you interested. Here's a nice sort of Confluence-esque dropdown. It's just got a few items in it. Looks quite pretty, nice Atlassian clean-cut style. But what's really nice about this is it's ridiculously easy to implement. So basically all it is a marked up, unordered list. So all you need to do is add a little HTML to your plugin view, spit out the items you want to have in the list. We've included some classes here just to add those little icons on the add those little icons on the left-hand side of those items. And then you invoke an AUI method called dropdown on a jQuery selector. So this actually functions as a jQuery plugin. You specify a couple of options. So we've just got the standard and the alignment, and then bam, that'll render it for you. So it's ridiculously easy to use. Just a really nice way of getting rich UI components in your plugin views really quickly. Let's take a look at a slightly more complex example, tooltips. Now this is a Crucible review tooltip from the Crucible plugin, from Crucible's core application actually. Tooltips are a really nice way of hiding away bits of UI and keeping it looking clean until the user actually needs to find out information about a particular element. They're also good for doing things like lazy loading. So if you've got an expensive operation, like in the Hovers plugin, whenever you hover over one of those links, it actually makes a remote request to the application to get that content. So yeah, if you want to lazily load expensive operations like that, tooltips are a great way to go too. But again, quite a complex thing, but it's ridiculously easy to implement with AUI. So here we've got we're using the Inline Dialogue the Inline Dialogue method rather, on the AJS object. Now, AJS is just a little namespace we've put in so that we don't conflict with other scripts in the page, just being a well-behaved plugin. You call inline dialogue with a bunch of different parameters. First of all, you just specify the class that you want to apply these to. We're just using an anchor in this case, but you can really apply dialogues to anything. Then we're just giving an ID for the rendered dialogue, so you can reference it if you want to interact with it further. And then we're providing an AJAX content URL. So when you hover over that particular, the trigger for that dialogue, that anchor, it'll fire off a request in the background, retrieve that content from, in this case, a REST URL, or a REST resource, and then render that tooltip inline for you. And we've also specified a few options. There's that on-hover option, so that's what actually makes it a tooltip in this case. If that's set to false, you'll actually have to click on the element. So I mean, that's kind of good for flyout dialogues and things like that. But yeah, in this case, we're just using it as a hover and a width. And that last one is cache content. So this is really good for just where you're trying to hide a complex or hide an expensive operation away from the user at page render time. If you set that to true, the first time you hover over the link, it'll pop out it'll make the request in the background and pop out the dialogue. And then the second time you hover over it, it'll have that dialogue already cached and preloaded. So it's smart enough not to go off and re-retrieve content that it already has. And yeah, that's it. Again, just ridiculously easy to do. So I won't go through any more AOE components, but the AOE plugin does offer a whole bunch more functionality if you're interested. There's things like modal dialogues, auto-completion, little SVG icons. In fact, AOE bundles a popular JavaScript graphics library called Raphael. It uses that to draw these little icons. You can have things like toolbars, messages, tables, tab bars, and even full-on forms. So if you're just writing a simple plugin, there's not really much that AOE doesn't cover for you. So highly recommend that you use it and give us some feedback on it. See how you like it. Just before I move on, I just wanted to, we won't go into too much detail here, but I just wanted to show you how it's a little more flexible. While it is quite simple to use, it can also be quite flexible and powerful. This is some more code from the Hovers plugin. This is what's actually used to bind those tooltips that we saw in the Hovers plugin to all of the different little links that reference external entities. So if you look down the bottom, we're calling the inline dialogue method. But instead of passing an AJAX URL, which it's going to retrieve content from, instead, we're passing in a load hover contents function. Now, this function is basically a callback, which the tooltip will invoke when the user hovers over the link and passes in some information that you can use, and another callback to actually display the pop-up. So the reason we had to do this is because each link references a different issue key, so we can't just have one static URL which will go off and get the content for us. We actually have to introspect that HTML element that triggers the dropdown, find out the key of the thing that we're targeting. We're using these little HTML5 data attributes to do that, and then fire off a request locally with that key as part of the REST URL. And yeah, then we get our content back, render it inline. And again, even though this is a slightly more complex example, the API is just really nice and clean and easy to use. Yeah, I think that's enough about AOE for the moment. Let's move on to the next module. Have you ever wanted to include a piece of JavaScript or CSS in every page in Confluence or Jira? Or have you ever wanted to make your plugin pluggable or open it up to external developers? Or have you ever wanted to build a single plugin that can be deployed in multiple applications, a cross-product plugin effectively? Well, believe it or not, these are all core features of the Atlassian plugins framework itself. So the plugins framework, while it also does all the heavy lifting of getting your plugin loaded and enabled, also provides a bunch of core components which you can use in your plugin to query the plugin system and also provide like a little bit of extra functionality. So just a kind of a basic library for your plugin to do things. Depending on plugins is a little bit like depending on the other plugins, with the exception of you don't need to specify component imports. Because the Atlassian plugin framework is actually embedded in the host application, you don't need to have these little component imports every time you want to use something. You can just inject it directly into whatever component you want or whatever view you're using. The component import is really just when you need to depend on a component which is provided by another plugin. So the first dependency you might consider importing is the Atlassian plugins web resource. This is the module which includes the web resource manager, which we were looking at before when you include AOE. So if you're wanting to use AOE and include it in your plugins views, you probably need to depend on this guy. The next dependency, Atlassian plugins core, contains all of the other components which we'll be talking about in this presentation. And most of the time, that's probably the place to go when you're looking to interact with the plugin system. There are a whole bunch of other plugin modules, some of which provide extra functionality, but I'd advise looking at the docs before you start messing with those. So yeah, the first bit of functionality I wanted to talk about from the plugin framework, now that we've imported it, is web resource contexts. Now again, Don mentioned this in his speech yesterday, so we'll go into too much detail. But basically, these web resource contexts are used to apply your own web resources to existing views in the host application. So here we've specified the ATL general context, and we've got a couple of script and CSS files. And what that's going to do is it's going to go off, so every time the application renders a view, it'll include those script and CSS files in that view. ATL general applies to every application view except for the admin screens. So this can be a really nice way to mess with the existing Jira or Confluence UI if you like. So ATL general is one of the ones which is consistent across all of the applications. There's also ATL admin, which is the reciprocal of the general. It just applies to the administration screens. And then there's the ATL user profile, which applies just to the user profile screens in each of the various applications. These are the only consistent cross-product ones at the moment. There are a whole bunch of specific ones for Jira and Confluence, but I won't go into them at the moment because this is really a demonstration of the platform in its unified sense. Now let's talk about custom plugin modules. So a plugin module is basically just any one of those elements that you see at the top level of your Atlassian plugin XML file. It's just basically a component that your plugin uses. You can define custom plugin modules so that other developers can add new classes or interfaces to your particular, well, not classes or interfaces, can add implementations of an interface that you control to your plugin. So basically, you can open up your plugin to external developers to add more stuff to. To define a custom module, first of all, you need to start off with some sort of interface or some sort of class that you want other developers to provide to you. So in this case, it's just I've just created an interface called MyModule. It could be anything. Basically, it could be like maybe some sort of content provider interface so that other developers can implement and provide content to my plugin, which I'll maybe render in my UI. Or it could be some sort of operation provided by another plugin that I'll be invoking. Regardless, once you've got this particular thing that you want other plugin developers to provide, you'll need to extend the abstract module descriptor class from plugin's core. Now, abstract module descriptor is a massive class with a whole bunch of functionality, and you can override and extend all sorts of different things to change the way that your module descriptors behave. But to just do a simple thing like get other developers to provide an auto-wide component, all you really need to do is override this getModule method. In fact, it's the only abstract method on the class, so it's the only one you really have to implement. So getModule is typed to whatever you've typed the descriptor to be. And its responsibility is to return an initialized module from what the external developer has provided. So in this case, we've just got a really simple descriptor. All the external developers have to provide is a class attribute, and that class attribute identifies the class which they've created, which we want our plugin to load. So creating that class and auto-wiring is dead easy in the latest version of, in the plugins framework since version 2.5. There's this thing called the module factory, which is a protected field on the parent class, so you can just use it. And what you want to do is invoke create module, pass in the module class name, and also the descriptor for context, and it'll return you back an auto-wide, it'll return you back an auto-wide component, which represents the class that they've specified. And it's really that easy. So when you look at the Atlassian plugin XML file down the bottom, the only other thing you have to do to get these custom module types working is to use the module type module to give the plugin system the location of your descriptor. So that just involves writing a little module type little module type element, giving it a key, and giving it the class of your descriptor. Now, unlike most modules, the key is actually quite important here. Rather than just being an ID, it's actually the string. It's actually the name that plugin developers will have to use as part of when they want to register one of your custom module types. So as you can see, I've just got a couple of examples below that called myDescriptor, which specify a couple of those classes. And yeah, so just make sure you call it something memorable, because that's going to be your extension point that other developers are going to be using. So now that I've shown you how to define a module type, that's really all there is to it. But we should take a quick look at how you're actually going to use these module types in your application. So here I've just got some simple service, I'll just call it my service, and we're injecting a component called the plugin accessor. Now the plugin accessor, again, is quite a large class which has a whole bunch of different methods on it for interacting with the plugin system. But the one we're interested in at the moment is this method getEnabledModulesByClass. So what this does is it goes off and queries the plugin system looking for all of those descriptors that we saw registered here that match the module type, that match the module that you've specified. So we've just passed in myModule.class and it returns a nicely typed list of those modules that have been implemented by all of the plugins in the system. So this queries across plugin boundaries to find all of the custom module types that other developers have registered to use with your plugin. And once you've got that nicely typed list, you can iterate through with it, do whatever you need to, and it's really that simple. So with quite a small amount of code, you can create custom module types and open your plugin up to extension. So just the last thing I want to talk about in the plugins framework before I move on is these descriptor application scopes. So this is only really useful if you're going to write a cross-product plugin. But basically what it does is it allows you to limit modules that you define in your Atlassian plugin XML file to just be loaded in a particular application. So with this, you can do some pretty powerful stuff, like have a single jar that can be deployed in multiple applications, or potentially have, well, that's basically all you can do with this, but it is quite a powerful technology. So up the top, we've defined a couple of web resources. They're both bound to the ATL general context, so they're going to be included in every single view of the application other than the admin screens. But the first one is a thing called pageintegration.js, which is purely for interacting with the Confluence UI, maybe adding some sort of widget. And the second one, issue integration, is purely for interacting with the Jira UI. So we don't want the Jira one to load in Confluence and vice versa. So the way we do this is just by scoping it with that application attribute, and it's really simple. Once you've added that, it's completely like the actual module itself, the web resource, isn't even considered by the plugin system when it's first loaded. So you don't end up with it rendered in your page views. Now the second couple of modules I've got defined here are component modules. Now this is a slightly more critical piece. With the first couple of JavaScript files, sure it might mess your application's UI up if you start it up in the wrong application. But with components, these particular classes that they're targeting, the page handler and the issue handler, are actually compiled against their respective APIs. So the page handler has some hard dependencies on Confluence classes, and the issue handler has some hard dependencies on Jira classes. So if you attempted to actually load this up as a component in Jira, or if you attempted to load the Confluence one up as a component in Jira, you'd end up with a whole bunch of class not found errors, and it would mess up your plugin Spring context, and the whole thing would fail to load. So in this case, this application attribute is critical to making your plugin deployable. That's the last technology I'm going to talk about in the plugins framework for the moment. There's heaps more though, so do go and have a look through the docs. But I thought I'd just show you how I'm using that in the Hovers plugin. So here we have our interface, which is going to form the basis of our custom module descriptor. The responsibility of the content provider is just to go off and search the local host application for some sort of information that relates to a key. So we've got implementations later, which we'll look at in the tick, for searching for Jira issues, and then that returns some rendered HTML, which represents that Jira issue, which then is displayed as a tooltip in that remote application. And then a similar one for Confluence pages, Bamboo builds, and so on. So here we're creating a subclass of that abstract module descriptor and initializing with content provider. Again, it's very thin. All it's doing is really auto-wiring the content provider that's been provided. The only other thing we've done here is we're providing some validation rules to validate that actual descriptor. So we've got this nice validation pattern class, which follows kind of a builder flow type layout for providing validation rules for validating the XML. And it's quite nice because you can supply here we're just making sure that there's definitely a class attribute present. And if there isn't a class attribute present, so as in if an external developer is attempting to extend your plugin and not quite doing it the correct way, they'll get a nice human-readable message saying, whoa, hey, there's no content provider class provided. So then they can go, oh, okay, go off and fix up their Atlassian plugin.xml file, reload their plugin, and live on happily. So this is just a nice sort of mechanism for providing feedback to developers that they're not doing something quite right. So once we've got that module descriptor implemented, we just need to register that module type in our Atlassian plugin XML file. So here we're registering it. We're providing the content provider key, which is just a memorable key for developers to extend it with, and specifying our module descriptor class. Then we've got a whole bunch of content provider implementations. Now, each of these implementations, because they're compiled against the particular APIs of each application, have been scoped to those particular applications. So custom module types are also a really nice way of building cross-product plugins, even if, sorry. So this is, while this isn't actually something that other developers may necessarily want to extend, it's a really nice way of segregating those different modules within your own plugin and ensuring that they only load in their respective applications. And here, I won't go into too much detail, but here's just where we're querying the plugin accessor, looking for all of those content provider classes which have been installed locally, and using them in a nice generic way to try and find hover HTML for a particular key. All right, I think that's enough about the plugins framework. Let's move on to the next component. Have you ever needed to render HTML outside of a Jira or Confluence action and had a hard time finding the APIs to do so in whichever application you're developing against? Or have you ever needed to pass back rendered HTML for use in an Ajax UI? Or have you ever wished you could use something a little more modern than Velocity 1.4 in Jira? Well, the Atlassian template renderer might help you out. Now, this is just a really simple component that really, its only responsibility is to provide a unified API for rendering templates in all of our applications. So I'll just move straight into looking at how we can include it. So here we've got a dependency on the Atlassian template renderer API. That's all you need to include. And the only component import that you'll need is, again, on the template renderer component. The template renderer has just got a really clean API. So rather than trying to look through various Jira managers and Confluence managers to figure out how you can render your Velocity fragments or templates, all you need to do is call this template renderer.render method. Pass in the name of a template, pass in a simple context for rendering your Velocity, and then just pass in the writer for the, in this case, we're just passing in the writer for a response. And there we go. All of our view information will be written straight out to that response. Again, just a really nice, clean way of rendering some Velocity wherever you like. It's also got another couple of methods on it, so you can render Velocity fragments and things if you want to work with like a RESTful UI and you want to return some, well, not a RESTful UI, but a REST resource, and you want to return some rendered HTML. Or you can use it to render JSON and things like that if you like. Here's just an example quickly of where we're using it. So if you look just inside that if state, this is from the, just to give you a bit of context, this is from the Jira content provider. This is an implementation of that custom module type we were looking at before that returns hover for a particular Jira issue. So we're calling the issue service to get an issue, injecting that into our Velocity context, and then just calling the template renderer to render our Jira issue view using that context. In this case, we're not writing out to a response, but rather just writing straight out to a string so that we can return that as part of the responsibilities of this component. And that's pretty much it for the template renderer. Just a really kind of small component, but quite easy to use, so I thought I'd include it. Now, moving on to the next component, have you ever needed to persist some simple data or configuration information for your plugin? Or have you ever wanted to internationalize your plugin to open it up to a broader range of users? Or have you ever needed to write an upgrade task to automatically upgrade your plugin's data between versions? Or have you ever wanted to schedule a recurring job or some sort of task that spans more than just a single request? If so, the Atlassian Shared Application Layer plugin may help you out. So the Shared Application Layer, or SAL, was a plugin originally invented by the Studio team to provide some sort of unified API for them to code against when they were trying to tie all of the various Atlassian products together into the Jira Studio suite. So what they did is they created a single API and then had a different implementation of this particular plugin in each of the host applications. So you can use it to, so you can basically use one unified API when you develop your plugins. Today, SAL is a repository of many varied and mystical wonders. It's got a large number of components, so I won't be going through, well, anywhere near all of them today. But I will show you some of the more interesting ones and hopefully just give you a general idea of what's available out there. But generally speaking, if you're ever trying to figure out how to do something in a plugin and you're sort of at a dead end, check SAL because it's got a large amount of functionality packed away in it. So the first thing you'll need to do is just add a dependency. There's just a single dependency to add on the SAL API. Then you'll need to add a component import, or one or more component imports, depending on which SAL components you want to inject into your plugin. So I'll just rattle off a few here just so I can give you a bit of an idea of the breadth of it. There's the Authentication Controller, which you can use to interact with the host application's authentication stack. There's the login URI provider, which basically just provides the login URI for the host application. That can be kind of useful if you want to redirect the user to the login page for some reason. There's the component locator, which allows you to interact with the host application's IOC container. There's the I8N resolver, which allows you to internationalize your plugin. We're looking at that in a tick. The locale resolver, which allows you to resolve the current user's locale. Request factory, which is that simple HTTP client-esque request factory that we looked at before. A search provider, which allows you to perform text searches on the underlying host application. A plugin upgrade manager, which allows you to register upgrade tasks to automatically upgrade your plugin's data. A user manager, which lets you resolve the current context user and interact with the user base of the application. An application properties service, which is basically just sort of a collection of properties that you can query about the host application. Things like the display name or the version number or the base URL. There's also a plugin settings factory, which is basically just a simple service for storing various bits of information. I wouldn't use it to store too much data, but it can store simple strings and lists and properties. So if you need to store like plugin configuration settings or something like that, it's quite appropriate. There's a project manager for querying what projects are configured in the host application, or spaces or repositories if you're in Fisheye or Confluence. And there's the plugin scheduler for creating recurring jobs or tasks. And plenty more. This is probably less than 30% of the services actually provided by Sal. So again, if you're stuck working on a particular problem and you can't figure out how to do something, probably check out the Sal APIs, because there might be something there to help you out. So I won't go through all of those components, but I'll just have a quick chat about a couple of them, which might be more salient for plugin developers. There's upgrade tasks. Upgrade tasks are really nice because you can make sure that you have this single task that checks what version of data the application is currently running with. So when you install a new version of the plugin, it'll automatically execute and upgrade your plugin's data to the new version. And they're really simple to write. All you need to do is implement this plugin upgrade task interface. You've got to supply a build number. That's basically the build number that you're going to be upgrading to. Just a short description that'll be written out to the UI and the logs. And then there's this do upgrade method where all the functionality happens. From this do upgrade method, you should pass back a collection of messages that prompt the user if something's gone a little bit pear-shaped during the upgrade. And you just have to provide the plugin key. Once you've implemented that interface, you need to expose it as a component so it can be picked up by Sal's plugin upgrade system. Registering your own component is really easy. All you need to do is define a component element in your XML file and specify the interface that you're implementing, in this case the plugin upgrade task. And so that the plugin upgrade system can actually pick it up, you need to make it a public component. That way when Sal queries for your upgrade tasks, it'll be visible and it'll upgrade it if it needs to. Let's just take a quick look at internationalization. I'm sure this will probably be old news for a lot of people, but I thought it'd just be handy to go through and to show how easy it really is to internationalize your plugin if you're still sticking to one language at the moment. First of all, you'll need to add a component import for the I8N resolver, and then you'll need to define a resource which targets an I8N properties file. Now, this is just a regular properties file. The standard for internationalization is just to append an underscore and a two-letter language code after it for your translations, and then you have a consistent set of keys so that when you query these internationalized strings later on, you'll get a different value for each of your languages. So using the I8N resolver, once you've got this initial stuff set up, is really easy. All you need to do is inject that I8N resolver component that we've added a component import for into any of your views. Generally, you'll put the actual I8N resolver into your velocity context, and then directly invoke it inside your view. So up the top, we've just got a view, say maybe a servlet or something like that. Again, we're using the template renderer to render the template, passing in the template we want to render, the context, which contains the I8N resolver, and some sort of writer, maybe just a response writer if it's a servlet. And then we're invoking the getText method on that I8N object and passing in the key that we want to display. And that will nicely internationalize text based on the user's locale. So no, you don't actually have to interact with the user's locale at all yourself here. That's all handled by the I8N resolver behind the scenes. And just a last example of what Sal can do. Let's take a look at scheduling jobs. So the first thing you need to do to schedule a job or task that you want your plugin to execute on maybe just once or on a regular basis is this plugin job interface. It just has one method which you have to implement, the execute method, and you pass in a map of data. Now this map of data you can basically put anything in there, and that'll be persistent across each job execution. So the next time this method is invoked, it will pass in the same map, and so you can use that to persist state if you need to. This is just a very contrived example. We're not actually doing anything useful. But if you ever need to schedule some sort of recurring job, then this is the place to do it. Once you've implemented this interface, you'll need to schedule it using the plugin scheduler component. So this requires another component import from Sal, targeting the plugin scheduler. And there's one slight trick with this. To actually register a job using the scheduler, you want to do it once the plugin system and the application itself have all fully started up. So what we've done here is we've defined a new component that implements lifecycle aware. Lifecycle aware is another Sal interface which has just one method on it on start, which will be invoked by Sal at some point. Which will be invoked at some point after the plugin system and the application have all started up. So yeah, once the application started up, you're free to call schedule job, pass in a name for the job, pass in your plugin job class, and that persistent map that we saw. So you can initialize that here, or you can just pass in a new hash map if you like. Give it the date that you want the job to first execute on. In this case, I'm just saying we should execute it immediately, and then the delay between occurrences. And that's about it for Sal. So as I said, I barely covered any of Sal's functionality here, but it's pretty cool. Check it out. So just to recap on why using the Atlassian platform is a good thing. For one, it's targeted directly at you. It's jam-packed full of features, as I've shown you some of today. I've probably covered, I don't know, less than 1% of the platform's functionality, definitely. It's got a dedicated team who are awaiting your feedback. It's got much better documentation than you're used to dealing with in the internal Confluence and Jira APIs. And it's got a much stronger focus, again, on backwards compatibility. So we hate it when your plugins break as well. It looks bad for us. We want to try and make sure that your plugins continue to function across upgrades of the platform. So we'll be making sure our APIs are backwards compatible. Also, as Don strenuously mentioned yesterday, it's open source. So if you ever feel like submitting a patch or even forking it, please do so. Or if you're just trying to figure out how something works, or you're trying to debug some sort of component, feel free to go to our public studio instance, check out the module that you're depending on, and see how it works under the covers. Also, since almost all of the things I've been shown to you today are implemented as plugins, it can be a really good idea to see how you can implement this kind of functionality in your plugin. And there's heaps of code examples you can check out. Yeah, so please, go and use it. Oh, and on a final note, I asked that survey I put out that survey at the beginning asking how many people were Jira developers and how many people were Confluence developers. If you start learning the platform APIs today, it won't be long, but you can sort of transfer that knowledge over to the other host applications. I mean, sure, there's still sort of Jira-specific APIs and Confluence APIs that you'll need to code against to add those features to Jira and Confluence. But if you start using the platform for all of that other plugin-y stuff that you need to perform, things like adding UI components or scheduling jobs or writing upgrade tasks, then you can transfer that knowledge to other products. So soon you won't just be writing for one product, but 5. Thanks very much for listening to me today. Are there any questions?